Dear students, now let us discuss about our new chapter that deals with the Bessel function and the gamma function. We know that what is a gamma function? Gamma function means the function of the integral is of the form integral 0 to infinity, that is the definite integral. Integral 0 to infinity e power minus x power n minus 1 dx. This definite integral for n greater than 0 is called a gamma function, or it is called the Eulerian integral of second kind. The gamma function is also called, this is called a gamma function, the definite integral. The definite integral, integral 0 to infinity e power minus x to the power n minus 1 dx, where n is positive, is called a gamma function. This is also called Eulerian integral of second kind. So that's the question, what is the Eulerian, which is the Eulerian integral of first kind? The Eulerian integral of first kind is known as the beta function, which is denoted by beta mn, and is defined as Bmn. It is defined as integral 0 to 1 x power m minus 1 1 minus x all to the power n minus 1 dx, where m and n are positive, m comma n greater than 0. So this is beta function, and this is also called the Eulerian integral of first kind. So the gamma function is said to be Eulerian integral of second kind and is denoted as it is gamma n. So this definite integral e to the integral 0 to infinity e power minus x power n minus 1 dx exists, or it should be valid only for this n greater than 0. That means this definite integral converges. This definite integral converges only for this n greater than 0. So this is the gamma function. So there is another function which is incomplete gamma function. There is also another term, incomplete gamma function. What is an incomplete gamma function? Incomplete gamma function means it is upper incomplete gamma function. It is denoted as gamma ax. Gamma ax. Gamma ax equals integral x to infinity e power minus t, or sorry, e power s integral e power minus t and t power a minus 1 dt, or e power minus x and x power a minus 1 dx. So this is the incomplete gamma function, or it is known as upper incomplete gamma function. Gamma ax, it is denoted as gamma ax. Gamma function is denoted as gamma n, that is the exponent of x. Here it is gamma ax. This is the upper incomplete gamma function. Agree? So now tell about the properties of this gamma function. What is gamma 1? Immediate gamma 1 equals 1. That is from here. Replace n by 1. It is integral 0 to infinity e power minus x dx. Then it should be 1. And what is gamma n plus 1? Gamma n plus 1. Gamma n plus 1 is, we know that gamma n plus 1, that is integral 0 to infinity e power minus x to the power n plus 1 minus 1, means x to the power n dx. Okay, so integration by parts. That is first function into, this first function into integral of second, means it is integral of second integral of e power minus x, that is minus e power minus x, or e power minus x by minus 1. From where to where? 0 to infinity. Minus integral 0 to infinity derivative of the first function, that is n x to the power n minus 1 into integral of second function e power minus x dx. If you apply the limit, this is actually limited, the second term, when x equals 0, this term vanishes. That is when applies the lower limit, the term vanishes. Applies the upper limit, when x equals infinity, limit x tends to infinity, x power n by e power x is always goes to 0. So this term the first term always goes to 0. Minus of minus plus. So it is n into integral 0 to infinity e power minus x to the power n minus 1 dx, which is nothing but gamma n. So finally we know that we got gamma n plus 1. Gamma n plus 1 is n into gamma n. Gamma n plus 1 is n into gamma n. Okay, so this is a important result. Now gamma n plus 1 is n into gamma n. For n is a non-negative integer. Suppose n is a non-negative integer. When n is a non-negative integer, what is gamma n or gamma n plus 1? So when n is a non-negative integer, we know that for n greater than 0, gamma n plus 1. This is n into gamma n. Okay. So this is nothing but n into when n, it is this gamma n is again rewrite as it is n minus 1 into gamma n minus 1. Then again it is n into n minus 1 into gamma n minus 1 is again rewrite as like this. It is n minus 2 into gamma n minus 2. So proceeding like continuously, finally you have it is n into n minus 1 into n minus 2 into etc. into it is 3 into 2 into 1. So finally it is nothing but n factorial. Okay, why? Because final time is gamma 1, so it is gamma 1 is nothing but a 1, so it is n factorial. So this is another result, that is when n is a non-negative integer, gamma n plus 1 is n factorial. Okay. So by using this argument, this n factorial, there is Gauss pi function. It is a Gauss pi function. Gauss pi function is defined as it is product n, pi n. Gauss pi function, it is pi n. Pi of n equals gamma n plus 1. This is the Gauss pi function is defined in terms of gamma function, that is pi of n equals gamma n plus 1. So when n is a non-negative integer, when n is a non-negative integer, Gauss pi function pi of n is n factorial. Why? Because we know that for a non-negative integer, gamma n plus 1 is n factorial. Agree? So what is now we already stated that this gamma function of the definite integral convergence for n greater than 0. So for n is a negative integer, what happens here? For n is negative. When n is negative, it will not be an integer. When n is negative, what happens here? When n is a negative, suppose n is a negative integer, what happens? Suppose n is a negative integer. Means when n equals minus 1, what happens? So we know that gamma n plus 1 equals n into gamma n. Okay. So this means, what is gamma n? Gamma n equals gamma n plus 1 by n. Agree. When n equals 0, what happens? For going to this one, when n equals 0, it is gamma 0. Gamma 0 means gamma 1 by 0. When n equals 0, gamma 0 equals gamma 1 by 0. We know that gamma 1 is 1. 1 by 0, it is an indeterminate quantity, means it is infinity. So gamma 0 is infinity. When n equals minus 1, so it is gamma minus 1 equals from here. Gamma minus 1 equals gamma minus 1 plus 1. It is gamma 0 by minus 1. Gamma 0 is infinity, so it is again infinity. When n equals minus 2, gamma minus 2. Gamma minus 2 in this equation, when n equals minus 2, it is gamma minus 1 by n equals minus 2. So it is again gamma minus 1 on numerator, which is infinity. So like this, you can see that for any negative integer, then gamma value of that negative integer should be infinity. So when n is negative, n is a negative integer, then what is gamma n? Gamma n is infinity. This is an important idea. So when n equals 0, n is a negative when n equals 0 or n is a negative integer, then the value of gamma n is always infinity. This is another important idea. That is, for any negative integer, gamma n is infinity, and when n equals 0, gamma n is also infinity. Now we choose another case. Suppose n is a negative real number, which is not an integer. N is a negative real number. N is negative. What happens here? N is negative, but n is not a. N is negative, but n is not a negative integer. It is not an integer, but it is a negative real number. What happens? Suppose n lies in between -1 and 0. That's a negative real number. Okay, n lies in between -1 and 0. -1 less than n, this should implies n plus 1 should be positive. -1 less than n means n plus 1 should be positive. We know that this gamma n is a well-defined function, means it is convergent, this definite integral convergent only when n is positive. It not be an integer n greater than 0. So when n plus 1 greater than 0, since n plus 1 greater than 0, then gamma n plus 1 is well defined. Okay, gamma n plus 1 is well defined. Why? Because n plus 1 greater than 0. So we know that gamma n is defined, or gamma n is defined. Gamma n plus 1 is well defined. What is gamma n plus 1? Gamma n plus 1 is n into gamma n. So what is gamma n? Gamma n equals gamma n plus 1 by n. So when gamma n plus 1 is well defined, n is a negative real number, then gamma n is also well defined. Okay, so we know that, then we can say that this gamma n is defined when gamma n is defined for -1 less than n less than 0. Okay, suppose -2 less than n less than -1. Again n is a negative real number. Again n is a negative real number, not a -1 and not -2, means it is not a negative integer. So for clearly when -2 less than n, surely n plus 2 should be positive. Then since n plus 2 is positive, then gamma n plus 2 is well defined. Okay, gamma n plus 2 is well defined. So we know that according to this idea, we know that gamma n is defined. Gamma n is defined for -2 less than n less than -1. So like this. So this is the behavior of gamma function for negative real numbers. Means gamma of a negative real number should be infinity. Gamma of 0 should be infinity. But gamma of a negative real number is well defined. Okay. Now we are going to an important result. Means the value of gamma half. Gamma half equals root pi. So this is another important character. Gamma half equals root pi. How to prove this one?